Hello, Lucinda. Thanks for this question. I love doing maths, and so it's very nice to feel useful. Please, by all means, send me any questions like this. I think this looks like really good fun anyway. So let's have a go. Okay, when I see something like this, um, firstly, I'm kind of thinking if I can simplify it, then it's probably going to be through multiplying the top and the bottom of the fraction by the same thing. In other words, multiplying by one, a bit like with rationalizing the denominator, but we're going to be trying to get rid of this cube root. Now, it might be easier to see what's going on. There's sort of a couple of tricks you might want to try here, but it might be easier if we let u equal 1 plus x, because it will just stop us writing down 1 plus x, and we can swap it back for 1 plus x in a moment. And also writing these all as index powers, so u to the third minus, now this is going to have to be u minus 1. That's where it gets a little bit annoying, really. That's going to be u minus 1 on the top, because if u is 1 plus x, then u minus 1 will be x. And then we're going to have, now be careful here, because you've got a 3 and a cube root there. Now that is going to be u squared to the power of a third. And if you think about it, if you've got u squared, and then you're doing to the power of a third, and then, yeah, sure, you're going to times by 3 at the end, but I think I've already written that down. That's going to be the same as 3u to the 2/3. So I'm going to write that down as 3u to the 2/3. And this is all going to be divided by u to the power of a third. Yeah. Now I want to make it clear this is just one possible approach actually to this question. There'll be many others, and people kind of do these kind of things in their own way, and there's not really normally much in the different approaches. But okay, so we've got this u to the third on the bottom. Now there's a variety of things we could do now, but I think what I'd prefer to do is multiply the top and the bottom by u to the power of 2/3. Now you might think, why would I want to multiply it by to the power of 2/3? Well, it just looks like it's going to end up a bit nicer there to me. So, u to the third times u to the 2/3, when you add those powers, you're going to get u to the power of 1, which is just u. So I've got rid of all the cube roots and, the annoying bits like that. That's what seems to me like a good idea. Now, I'm going to do that times by that. Now, don't forget, this should be treated as something in brackets. So you're going to have to multiply the first term by u to the power of 2/3 and the second term by u to the power of 2/3. Sorry, I've just got my children at the door of the shed. Give me a second, Isabel. Give me a second. Okay, so you get u to the power of 1 here. U to the power of 1 down there, if you like. Now, what about this bit? Well, if you look, the u to the 2/3 on the bottom of the fraction is going to cancel with a u to the 2/3, which you're timesing it by. So you just end up with u minus 1 over 3. Oh, that looks lovely, that does. I'm very happy with that. Oh, this is going to be a dream now. Now, okay, always be careful when you're taking away a fraction like that with a subtraction on the numerator. Put it in brackets. Brackets are good for you. I'm going to times top and bottom by 3 actually as well, just because I hate fractions within fractions. Notice each time here, I'm really timesing it by 1. Yeah, I'm timesing it here by 1 because 3 divided by 3 is 1. I don't know why I've got all those multiplication symbols there. That just looks a bit weird. But okay, so now I'm just going to times the top by 3. So I get 3u minus u minus 1 in brackets. Times the bottom by 3, I've just got 3u. 3u minus u is 2u, so it becomes 2u plus 1 over 3u. Oh, I'm going off my screen. Let me just take it a bit further down. So I get 2u plus 1 over 3u. And now I can just substitute back. And now what was it I said u was? I think it was x plus 1. And so I've got 2x plus 2 plus 1, which is 2x plus 3 over 3 times x plus 1. I expect that some students will have this written down in different ways, because if you think about it, that's the same as 2x plus 3 over 3x plus 3. Now you could even think of that, you can think of it in loads of ways actually. You might even choose to write it like this: 3x plus 3 over 3x plus 3. I don't know why I'm doing this at the end, by the way, Lucinda. It just seems a bit pointless in some ways. Minus x over 3x plus 3. So I'm just pointing out that some people may have a correct answer here, which looks different to mine, which is 1 minus x over 3x plus 3. It might be possible that some people have it written down like that. There's lots of ways of thinking about it, really. Okay, right. So I'm happy with that. Now, I tell you what as well, though. I'm never really happy until I've checked my answer. I think the final answer is this. Now, is there a way I can check? Well, let's pick pick a number which I can plug into this and see if the answer which pops out is the same as if I pop it into this, because then they should be identical, because this is supposed to be true. Really, strictly speaking, I should have a triple equals here all the way along, because these are supposed to be identical statements. They are not just equal, they are identical. Well, I could check by plugging in a number into here, which cube roots nicely. Say x equals 7, yeah? Because when you add 1 to 7, you get 8, and the cube root of 8 is 2. So we get 2 minus 7 divided by 3 times, this is where it's going to get messy, I think, actually. Well, no, it's not actually, because 8 squared is 64, and the cube root of 64 is 4. Sorry about that, I thought wrong. And then I'm dividing that by 2. So that's 2 minus 7/12 divided by 2. So that would be, what is that? 14, sorry, that would be the same as 24 over 12 minus 7 over 12 divided by 2, which is going to be the same as 16 over 12 divided by 2, which is 16 over 28. Okay, so hopefully, cross our fingers, we should get 16 over 28 when we plug in x's 7 down here. What do we get? 2 times 7 is 14, 15, 16, 17. Ooh, looks like I've done a subtraction wrong up here. You're probably laughing at me now. Nichols, you loser. Okay, so yeah, 24 minus 7 is in fact 17. Hopefully that's not news to you, but it would seem to be news to me. And then 3 times 7 is 21, plus 4, we get 24. And that's because, oh my God, this is what happens when I don't go to school for a week or two. 12 divided by 2 is 24. And we do get exactly the same answer from both methods. Just pretend if you're watching this video you didn't see the absolute shocking display of arithmetic here. I can only attempt to blame indigestion from my lunch earlier and not going into school for 2 weeks. Anyway, I hope that was useful, and yeah, remember, that never happened, that mistake. That never happened.